plan. From our first process, plan schedule management, we have a list of activities, we have activity attributes, milestone list. From our second process, define activities. From the sequence activities, we have project schedule network diagram and project document updates. So from estimate activity duration, we have duration estimates, basis of estimates, project document updates. From the develop schedule, we have schedule baseline, project schedule, schedule data, project documents, change requests, project calendars. Now let's talk about control schedule. From our developed schedule, we have our schedule baseline. So this is the process where we keep our project and adhere with the schedule baseline. As PMI says, the process of monitoring the status of the project to update the project schedule and manage changes to the schedule baseline. In this process, monitor the status of our schedule baseline, measuring project performance, examining schedule variances. Throughout our project, we monitor schedule baseline. Changes to the schedule baseline are only entertained through change control process. Integrated change control, in where we have planned how we will deal with the changes, how changes will be managed, who can request the changes, and how we will implement the changes. So this is a process where actually we check, is our project on track schedule wise. Our schedule baseline, we always compare our project's schedule with the schedule baseline. So we do variance check. There are many processes that we use to check if our project is on track or not. If it is not, we take preventive actions to bring our schedule back on track. So this is control schedule process. When we are using waterfall approach, we know we have idea about our activities. When will we start the activities? What is duration of the activities? We can sequence the activities. But using agile approach, before starting the iteration, we select a portion of the work. For example, we have selected 15 story points and we have completed only 10 during that iteration. So what happens before starting next iteration? We reprioritize the work. We see what consequences on our schedule will be there, why we are lack of 5 story points. So is there something wrong with the estimation? So for the next iteration in agile approach, what we are lacking in the current iteration, we discuss that and we try to eliminate all those weak points in the next iteration. So this is agile approach. So we control schedule by checking or comparing how many activities we have selected before starting the iteration and how many story points we have completed at the end of the iteration. Okay, inputs are project management plan. So we need schedule management plan, schedule baseline, scope baseline, performance measurement baseline. Project documents, we need lesson learned register, project calendars, project schedule, resource calendars, schedule data, work performance data, organizational process assets. So tool and technique, we need data analysis, earned value management, iteration burndown chart, performance reviews, trend analysis, variance analysis, what if scenario analysis, critical path method, project management information system, resource optimization, leads and lags, schedule compression. As an output, we will have work performance information, schedule forecast, change requests, project management plan updates, schedule management plan, schedule baseline, cost baseline, performance measurement baseline. Project documents are updated like assumption log, basis of estimates, lesson learned register, project schedule, resource calendars. earned value analysis. So this is a technique we use to compare our planned and actual values. So we use schedule variance, we use schedule performance index. So these we will discuss in detail in the cost management knowledge area. What is iteration burndown chart? This is a chart that we use to check our remaining work, like how many activities are remaining. So here you can see we have a set of activities on y-axis, and on the x-axis we have our duration in days. Say we have 300 tasks or 300 set of activities that we need to complete within 15 days. This orange line you can see is our planned value, like we have planned to complete all 300 tasks or activities in 15 days. So for that we can say we need to complete 20 activities every day to complete all 300 activities within 15 days. So what happens, we check our progress on day 9. So on day 9 we have planned that we should complete all the work except this 125 activities till here. Okay, but and this blue line you can see is our actual progress. So at day 9 actually we have completed only this much work, and we have approximately 175 activities remaining that were supposed to be 125 approximately, but we have 175. So based on our previous progress we draw another line. This, the green one you can see, is our forecast, like when will we complete all 300 tasks or activities. So we draw another line, that is our forecast, and we came to know that we need minimum 18 days to complete all 300 activities. So this is our variance. We plan to complete within 15 days, but on day 9 we track our progress and we draw another line stating that our work will be completed only on day 18, not 15. So this is a chart that is used to check our remaining work. This is a kind of controlling our schedule. We can use this chart to control our schedule, like how much we planned and what we have achieved. Another tool and technique we use to control our schedule is performance review, where we measure performance against our schedule baseline, like what is our percent complete, what duration is remaining. For example, our project is 30 days long, and on day 15 we check have we completed 50% of the work and 50% is remaining, or we have completed 40% and 60% is remaining. So this is a performance review. We check, compare our performance against schedule baseline. So trend analysis is used to check our work performance. Where will we end up? Like based on our past experience, we can predict future, like during execution at a specific point, what is our planned progress and what is our actual progress. So based on that we can see will we end up on time or we will be late. So this is a trend analysis. Variance analysis, we check the deviation between our planned value against actual performance. So for example, for the schedule we have schedule variance, SV is equal to earned value minus planned value. For example, we have calculated that we have earned 10 units, and actually we have planned 12 units. So we are 2 units less than what we have planned. So it could be duration, like for example, we have estimated to complete 12 units within 10 days, but on the day 5 we came to know that we have completed only 5 units, not 6. That was supposed to be 6. So we can check the variance between what we have planned and what we have achieved. What if scenario we have discussed before. This is a tool and technique in data analysis that we use to bring our schedule back on track. For example, middle of the project we came to know that we are behind schedule. Now, to bring our schedule back on track, we use what if scenario. So we assess different scenarios. What will happen if we do X, Y, Z? For example, we say what will happen if we do crashing? What will happen if we do fast tracking? What if we put extra labor on the critical activities? What if we outsource portion of the work? So we discuss different scenarios. We assess different scenarios to bring our schedule back on track. So this is an example of what if scenario. Critical path method. So we have explained in our previous lecture about critical path method. The longest path in a schedule is critical path. So if any activity on critical path is delayed, it will impact the project schedule. The whole project duration will be prolonged. So for example, if one activity is delayed for 5 days and that activity is on critical path, our project will be delayed for 5 days. So if that activity is not on critical path, so maybe that delay will not impact on the overall duration of the project. So critical path method, we have to analyze our critical path method during controlling our schedule. So complete our project as per the schedule baseline. We have to work on critical activities. Software will help us to control our schedule more efficiently. So we use Primavera, MS Project, or there are a lot of softwares that we can use to control our schedule. It will highlight a lot of things for us. It will make our work easy. So for example, it will tell us about critical path, which one is our critical path. We don't have to find out manually. So about the resources and variance, we can check using this software. All we need to do is to enter the data and it will automatically calculate for us, like we are behind schedule, we are ahead of schedule, we need some improvements on critical path. So project management information system we need as a tool and technique in control schedule process. As a project manager, you should be able to utilize your resources in efficient way. So based on the project scenario, we can do resource leveling, we can do resource smoothing. Sometimes we need to put some extra hours for the critical activities so that we can adhere our critical path. Sometimes we do resource leveling. So as a project manager, you should be able to know where to do resource leveling and when to do resource smoothing. Another tool and technique we use to control our schedule is leads and lags. So we should be aware of doing activities in advance or delayed with relation to predecessor activities. This is to keep our project on track or bring it back on schedule. So we also do schedule compression. If we need to compress our schedule, we do crashing, like we add extra resources for the critical activities so that we can complete it earlier, or we can do some activities, sequencing activities in parallel, and that activities should be on critical path, should be critical activities. As an output, we have project performance Like based on this information, we can take our preventive actions if our project is on track, if our project is behind schedule, ahead of schedule. So we can, based on this information, we can take necessary actions. So based on the work performance information, we can predict our schedule. Like this information is based on our past experience, and using our experience and taking corrective or preventive actions, we can easily forecast our schedule. For example, we have planned 100 days duration for our project. So on day 30, we realize that we need another 100 days to complete the project. There are some activities that are going to take longer, and in past 30 days, we realize that there are some activities that were not estimated properly, their duration was not estimated, so we need another 100 days to complete the project rather than 70 days. So this is schedule forecast. So as an output, we have project management plan updates, like schedule management plan is updated, schedule baseline is updated, cost baseline is updated, performance measurement baseline is updated, project documents are updated like assumption log, basis of estimates, lesson learned register, project schedule, and resources calendar.